Students, this is Unit 6 Polygons, Lesson 6.3, Rectangles, Rhombis, and Squares. Taking a look here at your video notes, make sure you get the date, time, location, and a parent sign-off. This page you want to review on your own. When you're ready, restart the video. Pause the video, do your own work. Welcome back. Let's see how you did here. So first off, you should have recognized that opposite angles are congruent. So we find these two, and that's going to be 115. And then this is also 115. And then we know consecutive interior angles add up to 180, which would make this 65 and this 65. Now you can find your variables. 5y equals 65. Y equals 13. Right here we have 7x minus 5 equals 65. X equals 7. Double check your work. You should be correcting in a red pen. This one is a regular polygon, has a single exterior angle that is 36 degrees. What is that polygon called? The fact that that's poly means we don't know our end. It's exterior, and it's 1. Now we're going to circle flag check. Of course, n is 10, but I don't ask you just for that. It is a decagon. So today we're going to be focused still on the family of parallelograms, and we're going to be taking a look at rectangles, rhombi, and squares. And they're all interrelated. But because both a rectangle, a rhombus, and a square are all themselves parallelograms, let's recap what we know about a parallelogram. And that is OCD. Knowing that, opposite sides are parallel. Get in the habit of automatically stretching everything out, because that's how you recognize your alt-in, alt-x, corresponding and consecutive interior angles. They're also obviously congruent in length. You should be able to rattle these off. You should be able to finish this list even before I do, writing this down. Squiggle consecutive interior, put a little caret there. They're supplementary. And those diagonals, of course, they cut each other in half. That's a midpoint. They do not cut the corners in half in just a parallelogram. So these are the OCD qualities of a parallelogram. Now we're going to ask ourselves specifically what makes a parallelogram become a rectangle or a rhombus. You can see here, if you take a rectangle and make all four corner angles 90 degrees, so all the qualities of a parallelogram, and you simply make all the corners exactly 90, then you get a parallelogram. Very simply put, a rectangle is a parallelogram with four right angles. A rectangle is a parallelogram with four right angles. Now, if you take a parallelogram and you simply make all four sides equal, then you get a rhombus. So if you make four right angles, you get a rectangle. If you make four equal sides, you get a rhombus. That last should say four congruent sides, not four congruent angles. So then, you start with the parallelogram. You make four right angles, you have yourself a rectangle. You make four equal sides, and you have yourself a rhombus. So both a rectangle and a rhombus are parallelograms. So they have all the OCD qualities, but they each have two additional qualities. A rectangle, the additional quality, of course, is that first start, the fact that you have four right angle corners. The second quality is go ahead and draw in one diagonal. You can do this in two different colors. It's really helpful. Go ahead and draw in another diagonal. I'll wait for you to draw that in two different colors. Now, put your fingers right there on those two giant dots and kind of pinch that measurement. Now, swing around and put your fingers right here and compare the same length. What you should have noticed is that the length of this diagonal is the same as the length of that diagonal. So we have congruent diagonal lengths. Now, because those lengths are equal and a midpoint, so we have four equal pieces. This is very critical because all four of those pieces are equal. You end up with isosceles triangles here. So just showed one of them. There's four of them there, as you can see, all the way around. But keep in mind, when you have a rectangle, you're going to end up with a bunch of isosceles triangles. Now, in a rhombus, rectangle, you have four right angle corners. In a rhombus, you have four congruent side lengths. But now the diagonals themselves have two very important qualities. Let's zoom in here. I'd like you to draw in the diagonals of a rhombus. Now physically retrace those. You probably can feel it. Can you feel that those diagonals are perpendicular to each other? So you have a right angle in the middle there. Also, those diagonals bisect the corners. This only happens in a rhombus, not a rectangle. The diagonals bisect the corners. So you have two additional qualities in a rhombus. The diagonals are first perpendicular, comma, they also bisect the corners. Take a moment, pause the video, and verbally recap to yourself what are the two additional qualities of both a rectangle and a rhombus beyond the OCD qualities. Pause the video, verbally recap these. All right, welcome back. Now you're probably wondering, what about a square? Well, a square is very simple. Here are all the qualities of all your quad family trees. You will need to memorize this. You will recognize right here the OCD qualities, and then the three additional, the qualities of a rectangle and the additional, of a rhombus, the additional qualities of a rectangle. So here's the parallelogram. Here are the qualities of the rectangle, rhombus. So both a rectangle and a rhombus are a type of a parallelogram. Now, if you think about it, if a rectangle and a rhombus get married and have a kid, their kid's going to be a square. That means the square has all the qualities of a rectangle, including the four right angles. And it has all the qualities of a rhombus, including diagonals that make a right angle and bisect the corner. So when you've got a square, you've got everything under the sun happening. Alright, it is so important you understand how much information you get just by telling if you have a rectangle, a rhombus, or a square. So we're going to walk through two problems together. It says in the rectangle below, so it's a rectangle. Trace and mark the given information on the diagram. Then find all possible angles and sides. So before I do anything, let's just mark what we know is true about a rectangle. Just start marking. The minute you see that, start marking everything you know is true. Got parallel sides going on, I got congruent sides going on, I got right angle corners, and remember you also have an isosceles triangle, 4 of them technically. Okay, so let's mark our given information on the diagram. We know E to I from here to here. If you can color code this, that'd be great. And F to H. And then IFH, IFG, excuse me. There's I, there's F, there's G, sweep 51. All right, we want to find everything possible. Let's zoom in here. The angles are easier to do, so let's do that first. Step number 1, because opposite sides are parallel, let's do our armpits of the Z right off the bat. Armpits of the Z. You can instantly see where else that 51 goes. Right here, you also notice we have an isosceles triangle. So if this is 51, that's 51. Now we know that we have 90 degrees here, so we're going to go 90 minus 51. Of course, we have 39. Isosceles, 39. And of course, because of armpits of the Z, like this, you can bring that 31 up. 39, excuse me, 39. Isosceles, 39. 51. 51. There's a ton of information. And then because triangles add up to 180, 51 plus 51 is 102. Take away from 180, and of course we get right here, we get 72 degrees, which makes this 108, 72, 108. You can double check your math, of course, because this is going to add up to 360. So look how much information. Just because you know it's a rectangle, you can find every single angle. Now let's focus on now the segments. We are told if you color code this from here to here is red, that's 2x plus 1. And then from here to here, I have in blue, and that is 3x plus 10. Super important you do things before algebra. Things first. So if you look at that physically, I know that EI is only half of FH. The red is half the blue. Makes sense. Or another way you can say it is this. FH is 2 EIs. In other words, it takes 2 reds to get a blue. Always do a thing equation first. Color code it. Your brain will recognize colors before numbers. So it takes 2 reds to make a blue. Knowing that, now we can do circle, plug, chug. FH is going to be 3x plus 10 2 EIs, which EI, 2x plus 1. Distribute, solve for x. Now, don't get all happy with x. Let's plug it in and double check your work. So if we think x is 8, we're going to plug it in right here. 2 times 8 is 16. plus 1, that makes this 17. That would make that 17. And then 3 times 8 is 24, plus 10, that would make this whole thing 34. So 3 times 8, that's the blue, plus 10. And I know I'm correct because 2 17s equals 34. So from the middle, all of these pieces are going to be 17, whatever units we're using. Now, it looks like you have everything, right? But wait, there's more. I'd like you to grab nice dark highlighter here. Take a look. Always watch out for right triangles. Do you see that right triangle? That nice big overlapping right triangle? Let's pull it out down below, because when I say find all angles and sides, I mean it. And you think you have all the angles, which you do, but you do not have all the sides. So we're going to take this triangle right here, EHG, and just pull it apart. Let's bring down it's 51 degrees, 39 degrees. And this whole edge right from here to here is not 17, it's 34. Recognize this, folks? Now we're back to SOHCAH TOA. We're going to solve for the outer side lengths. I'm going to go ahead and use 2 different colors here. This outer edge, I'm going to call this edge X. I'm going to call this edge Y. Now I have both angles, so it doesn't matter which one I'm going to use. You just have to choose one. I'm going to go ahead and choose the 39. Go sweep 39. And ready? Let's label. That's going to make X our opposite. That's going to make Y our adjacent. So we're going to solve for X and Y. So have, need, do, folks. Have, need, do. Solving for X, we have the opposite. Excuse me, we don't have the opposite. We have the hypo. And we want the opposite. I have an OH combo, so of course I'm going to use sine. So we write our equation out. Sine of theta over 1 equals opposite over hypo. Of course, that's going to be sine of 39 degrees So if you cross multiply, x is going to equal 34 times sine 39. Get out your calculator, do this yourself. Make sure you match mine. 39 sine times 34. We're going to take that to the second decimal place, 21.396, because that 39 rounds up. We're just going to call it at 21.4. 21.4. Have need do for y. For y, we have the hypo. We need the adjacent. Of course, that's cosine. Cross multiply. So 34 times cosine 39 is going to equal y. Once again, you get your calculators out. And I get 26.42. So we're going to bring those numbers up here. So and for our final version of this rectangle, these outer edges, first off, let's do left and right. That's going to be 21.4. Top and bottom, 26.42. So you can see when you get a rectangle, you get a ton of information. So watch out for larger overlapping right triangles. And any time you have a right triangle, you have the possibility of one of those 5 right triangle tools: Pythagorean Theorem, 30, 60, 90, 45, 45, 90, SOH CAH TOA, inverse SOH CAH TOA. That's why you have to have those memorized. All right, now a rhombus has all kinds of information as well. Taking a look here, it says that we have a rhombus. Find all possible angles and sides. Now, rhombus has all of these qualities here, and specific qualities of a rhombus is diagonals are perpendicular. They also bisect opposite angles. So on top of the OCD qualities, which are right there, 1, 2, 3, 4, 5, it has those 2 additional qualities. So let's come down here and let's just mark everything. Always get in the habit of marking everything. So I have bisected corners. This only happens in a rhombus. I also have right angles in the middle here. And I also know that all 4 sides are congruent all the way around, all 4 of them. Now, let's get our given information on the diagram. We know P to R is 10. And instantly, because that's a bisector, I'm just going to automatically split it up. I know Q to R is 13. And I know TQR is 23. TQR is 23 degrees. Our goal is to find all possible angles and sides. Let's go ahead and do the angles first. They're usually easier. So right off the bat, because that's 23, this is 23. We know opposite angles are equal, so that means over here, of course, we have 23 as well and 23 as well. We have a right angle here, so if you see that right triangle right here, we can simply add the 23 and the 90. Take it away from 180. Of course, we get 67. Because the diagonals bisect, that's 67. Opposite angles equal, that's 67, and that's 67. Let's work on the sides now. Because one side is 13, automatically all 4 sides are going to be 13. The only thing we have yet to find is this segment right there. So let's pull this triangle out, this yellow one, so we can work with it. It makes it easier. We have 5, we have 13, we have 23 degrees, 67 degrees. We have a right angle. Now, let's take a look. We have an angle inside, so we could use SOH CAH TOA, and if you want to use SOH CAH TOA to find this missing side, be my guest. But we also have 2 sides, need 3rd side. We have 2 sides, and we need a 3rd side. You recognize that? That's Pythagorean Theorem. So we have leg squared plus leg squared equals hypo squared. Circle, plug, chug. Do your own math. So we just found that that edge there is 12. And we have completed finding absolutely everything. Could have used SOH CAH TOA if you'd like. So keep in mind, sometimes you have choices. Okay, that's a rectangle and a rhombus. This last one is a square. Remember, a square has all the qualities of a rectangle and a rhombus. And the only thing you are given here is the fact that A all the way to C is 12. I'd like you to pause the video and find everything possible on your own. Then restart. Okay, students, welcome back. Now, because it's a rectangle, we have 4 right angles. But because it's also a rhombus, those right angles are bisected. So you should have instantly figured out that we have ourselves a bunch of 45, 45, 90, leg, 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 root 2. That 12 is cut in half, which means all of these pieces are 6 and 6, 6 and 6. Go ahead and highlight 1. There is a 45, 45, 90, leg, 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 root 2. So your outer edge is 6 root 2, and because it's a rhombus, the 6 root 2 walks all the way around. You also have right angles in the middle because it's a rhombus, and right angles in the corners because it's a rectangle. Remember, a square has all the qualities of both a rectangle and a rhombus. Take 2 minutes. Set your phone for 2 minutes. This is very critical, and just verbally recap. Flip through all the pages, verbally recap to yourself a couple main concepts from each page.